Alright, ladies and gents, now that you have learned all of the rules for congruence, side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse leg, we're going to talk about how to actually prove each of those. So I want you to look at what I have right here. You'll see that there are two triangles that are drawn, and this is more of a formal proof, okay? So you are given that angle D is congruent to angle B. You can see that on the picture. You're also given that angle A is congruent to angle C, and you have to prove that triangle ABC is congruent to triangle CDA. Now, you can look at this, and the first thing that you probably are thinking is, oh, well, obviously they're congruent by angle, angle, side. Okay, that's perfectly fine, but the problem is now you have to prove it. So, one of the ways that you can do this is with what we call a two-column proof. Some of you may remember this from last year. On one side, you have your statements, and on the other side, you have your reasons. So, our first statement is going to be our givens, okay? Now, you always start with what you're given. So, our first statement is angle B is congruent to angle D, and our reason given. Our other one, angle A is congruent to angle C, again, our reason given. Now you're looking at this and you're thinking, oh, well, it's angle, angle, side, because you know that there's a shared side. AC is a shared side, okay? We all know that. But we have to prove it. So we talk about the AC that's in one of the triangles and the AC that's in the other triangle. So first, I'm going to talk about the AC that's in triangle ABC, and all I have to do is put AC, okay? So this is the this is the AC that's in the triangle ABC. Now, we also know that AC is shared with the other triangle, the CDA, so we have to say that AC is congruent to AC. So this is talking about the line that is shared in each of them, AC from triangle ABC and the AC that's in triangle CDA. If you'll remember from your last video, there is a term for when you say that something is congruent to itself. It was one of the properties. In this case, it is called the reflexive property. Alright, so now we have proven two angles are congruent to each other, another two angles are congruent to each other, and now we've proven that two sides are congruent to each other. So now we can officially say and prove that triangle ABC is congruent to triangle CDA by angle, angle, side. And that is a formal two-column proof. Now, we're going to be looking at some more informal ways to do this on Wednesday and Thursday. If you're watching this afterwards, you know what I'm talking about. If you're watching it before, for some reason, the video paused. I don't want to re-record the whole thing. So, this is a formal proof. We're going to be working with informal proofs on Wednesday and Thursday and how to start manipulating these. But this is what our goal is. So, look at it, understand it, this is where we're headed.